Okay, we're going to pick up where we left off. We're still covering section 2.1. We still want to graph this function y equals x squared minus 4. Again, this is a y equals, so you can do this on your calculator, but let's do it by hand first. So let's find some ordered pairs. So I need to draw a table of values. Again, let's let x be 0 and see what we get for y. If x is 0, I get y equals 0 minus 4, which is just negative 4. So when x is 0, y is negative 4. Now let's let y be 0. If I let y be 0, then I get 0 equals x squared minus 4. Well, hopefully you remember from chapter 1, I can bring this 4 over, and I get 4 equals x squared. To solve this, I can use the square root method. I have an x squared on one side, constant on the other. All I have to do is take the square root of both sides, but don't forget we also need plus or minus. So plus or minus square root of 4 equals the square root of x squared. Well, remember the square and the square root cancel each other out, so you have x equals plus or minus the square root of 4 is 2. So I actually have two values here. I have 2 and negative 2. So I actually have two ordered pairs when y is 0. 2 and negative 2. So by finding the intercepts, I actually found 3 points for this problem. Let's plot those points. 0, negative 4, 2, 0, and negative 2, 0. Well, obviously this is not a line either. Hopefully you can see that this looks like a parabola. Anytime you have a quadratic equation, you're going to have a parabola. Now it may face downward or it may face upward. You will study more about parabolas in chapter 3. Let's look at D. Hopefully you know these bars mean absolute value. Again, just like a square root, an absolute value cannot equal a negative. So I know y is never negative here. Now x can be negative or positive or 0. But when I take the absolute value of what's inside the bars, I'm never going to get a negative. So I know y is not going to be negative. Well, let's look at a table of values. Let's let x be 0. If x is 0, I get y equals the absolute value of 0 minus 4. That's negative 4, but then when I take the absolute value of negative 4, I get positive 4. So when x is 0, y is 4. Now, what number do you think would give me 0 for y? If I plug in what number for x, would I get 0 here? Yes, that's correct, 4. 4 minus 4 is 0, and the absolute value of 0 is 0. So when x is 4, y is 0. Let's come up with one other number. Let's plug in something for x. We have 0 and we have 4. Let's just say, since x can be positive or negative, let's say x is negative 4. If x is negative 4, that gives me y equals the absolute value of negative 4 minus 4. Well, negative 4 minus 4 is negative 8. The absolute value of negative 8 is 8. So when x is negative 4, y is 8. So let's look at these points. 0, 4, 4, 0, negative 4, negative 4, 8. Now, let's look at what this looks like on a graph. If I just use those 3 points, if I connect those points, it's going to be a line. I can tell you this graph is not a line. So we didn't pick very good points on this one. But this one is y equals. So I can do this in my calculator. Let's do this. Again, go to y equals on your calculator. If you have anything there, go ahead and clear it. Now, I need absolute value. I found the square root button a while ago, but if you look, there is no button for absolute value bars. So to get absolute value on your calculator, you actually have to hit Math, then go over to NUM, and then the first thing you see is ABS. That stands for absolute value. Hit Enter. Now your calculator may look like mine and say ABS, or if it's more updated, you will actually see vertical bars here that represent absolute value. Either way, it means absolute value. Now inside the parentheses, or inside the bars if that's what your calculator does, type what is on the paper inside the bars. X minus 4. Close parentheses. Graph. Well, here is what we had, right? If we connect our dots, we get this part of the graph. But as you can see, we're missing this part of the graph. Anytime you have an absolute value, it's going to come to a point. It looks kind of like a parabola, but it's not smooth, it's pointed. So if you go back to your paper, you can, let me do that. If you go back to your paper, you can connect these dots. This is part of your graph, but that's not all of your graph. And remember, we can't keep going because we already discussed y cannot be negative. So now it has to go back up. And it does keep going on both sides. So this is what absolute value equations look like. Okay, what are intercepts? Well, we've already talked about that. An x-intercept is where it crosses the x-axis. A y-intercept is where it crosses the y-axis. How do you find the x-intercept? You let y equal 0. How do you find the y-intercept? You let x equal 0. Now you can go to your ebook and in this section 2.1 try exercises 11A, 11B, 49, and 51. The answers are in the back, but since this is not a paper copy, if you just go to the side of your table of contents, you will see answers to selected exercises. Click that and check these answers before moving on to the next section. This concludes section 2.1.